back to factoring, but not like factoring. We don't have to necessarily do the box today or do whatever method you like for factoring. We have two types of special cases when it comes to factoring. So we're going to look at both cases. The first case is called a perfect square trinomial. So let's break that down. What does a perfect square mean? Okay, so give me an example of a perfect square. 36. How come 36 is a perfect square? Okay, so what's a different way I could write 36? 6 squared. Yeah. So a perfect square means it can be rewritten as just something being squared. So a perfect square trinomial means, what does trinomial mean? 3. It has 3 terms. So it means you're starting with a trinomial, something with 3 terms, but it can be rewritten as something squared. Now there's ways to tell if something is going to be a perfect square trinomial, and that's what we're going to go over today. So we're factoring this problem. You just don't have to use the box or anything for it. How to check. First term. Look at that first term. Is that a perfect square? What's the square root of x squared? Okay. Last term. Is that a perfect square? Okay. What's the square root of it? Okay. Just because the first and the last terms are perfect square doesn't make it a perfect square trinomial. There's something else you also have to check. What we are also checking, this middle term. That middle term is important. These come into play when it comes to that middle term. Multiply these two things together. So what's x times 6? 6x, and now double 6x. What do you get? Is that what we have right here? Then that means it's a perfect square trinomial. Whatever that sign is, that first sign, that's what goes inside our parentheses. So if you were to actually factor this, like going back to doing the long way of factoring, first term in the first box, last term in the last box, and then what numbers multiply to give you 36 but add up to 12? 6 and 6. That's why we have to double those two numbers when we multiply them together, because it's in both boxes, 6x and 6x. This is also on your formula chart. So I don't know if y'all ever like just look at your formula chart and like, what is math? What other math things are we gonna learn? No? Yes?
No.
That's okay. But on your formula chart, it's labeled as perfect square trinomials. It gives you that general form. This is the very first thing on your formula chart. The very top. It's exactly showing the trick. Because the first term should match with that first term squared. The second term in your perfect square should match with that last term squared. And then the two of these multiplied together and then doubled. Go here. So it's on your formula chart. I know when I was back in algebra, looking at that, I always thought it was kind of weird. It's not hard to catch on to the trick, so hopefully you don't have to actually like use that form. Okay, so let's go to this next example. First term. Can we take the square root of it? What is it? What's the square root of g squared? Last term is a perfect square. Okay, then what's the square root of it? Okay. Now, just because the first and last are perfect squares doesn't make it a perfect square trinomial. You have to check that middle term. Multiply these together, and then double it. What do you get?
4.
Is that what we have matching?
No.
Well, what's different?
-7.
Okay, so if I put a minus sign here and now multiply them together, that would give me -7g, and then doubling that, which is, so does it match?
No.
Okay, so that means it's a perfect square trinomial, and instead of doing our factoring steps, we can just cut straight there. If you had done your factoring steps, you would have gotten that your two parentheses were g minus 7 and g minus 7. But what's a different way of writing g minus 7? G minus 7 squared. Okay, let's look at the last, or the next one. First term, is that a perfect square? Can we take the square root of, what's the square root of 2y squared? Or sorry, 4y squared. This should be a y. Sorry. What about the last term? Is that a perfect square?
Yeah.
What's the square root of it? Okay. Now if we multiply those numbers together, 2y and 9, it's 18y. And so if we double 18y, what does that give you? Does that match our middle term? Yes, that means instead of having to do factoring steps, we can say it's a perfect square trinomial. This is designed to just speed up your process. Instead of having to go through factoring steps every single time, because if you wanted to factor this, your first step would have been multiplying 4 times 81. And then finding numbers that multiply to give you 324, but add up to 36. Doesn't sound fun to me. So that's the purpose of this. Just showing little ways to help speed up factoring if possible. If it's not a perfect square trinomial, back to factoring like normal. Okay, so flip to the next page. Flip to the back. We're going to look at number 6. On number 6, we have a trinomial. It has 3 terms. Is the first term a perfect square? What's the square root of it? Is the last term a perfect square? Yes. What's the square root of that? 3. Okay. Now, if we were to multiply 5x and 3, that would give you 15, and then double it. Does that give you your middle term? Could you make it give you your middle term? How? Put a minus sign in between it, which means instead of doing factoring steps, that is a perfect square trinomial. I write perfect square trinomial instead of having to write out those words. Perfect square trinomial, PST. You're going to see that on some worksheets and on your quiz. So if you see PST, that's what it's talking about. No. Okay. Let's look at 5. On number 5, 3 terms. Is the first term a perfect square? Is the last term a perfect square? Okay, then that means it has potential for being a perfect square trinomial. Square root of first term is x, square root of the last term is 10. So now, check the middle term. Multiply those things together and double it. Do those work? Because what should be in the middle? What number should be in the middle? 20, right? Whether it's positive or negative 20, that would be fine. But it has to be 20. We have 21, which means this is not a perfect square trinomial, but it doesn't mean that we can't factor it. Just because it's not one of our special cases doesn't mean you can't factor it. You can always go back and try factoring. So we have 100 and we have x squared. Numbers that multiply to give you 100, but add up to negative 21. What are some numbers that multiply to give us 100? 10 and 10. Those would be our 2 factors if it was a perfect square trinomial. They're the same thing. So what's something else that multiplies to give you 100?
25 and 4.
Okay, 4 and 25. Does that work? Okay, if I make the 25 negative, does that still fit into both things we need to pick to?
No.
It needs to add up to negative 21, but what else has to be true about it? Multiply to give you 100. Do those multiply to give you 100? No, they multiply to give you negative 100. So, okay, well, what if we make them both negative? Does that now satisfy both?
No.
Okay, so what's something else? 5 and 20? No. 2 and 50? Okay. Any other factors that multiply to get us 100?
1 and 100.
1 and 100. Okay, are those gonna work? Okay. So what do we do if nothing factors? There are no factors for it. Prime.
This is my answer for all my
Prime numbers are
that one.
Okay.
I just put my one.
do not do that.
Most times you do not have prime.
I put five.
Okay, go back to the front. Let's look at another special case. So the special case we just looked at was perfect square trinomials. This is our second type of special case. This is standard form. Yes, it is a binomial. So what part is missing? Bx, the middle part. When we have these area models, we could have something here, and then we have negative 100 down there. Well, what has to be in these two spots to make that middle term disappear? Cancel, things that cancel. Well, how do things cancel? They're the exact same thing. One is positive, one is negative. So then what would those two parentheses be? What would be on the top? X plus 10. So this would be our factored version. But how can we get from here to here a little bit faster? Like, what's the trick? What do you know about this down to our two answers? And then what do you know about this down to our two parentheses? It's square root again. How confident? Okay. So let's go to the next one. Perfect square, or sorry, the difference of two squares. It has to be two terms. Because it has to be two terms, so something, that middle term has to cancel out. So we have two terms. Are they both perfect squares? Could we get the square root of the first term and the second term? Okay, what's the square root of the first term? 2m. And what's the square root of the second term? Okay. Can I just put a square here and be done with it? How do they cancel? Same thing, but one is positive, one is negative. That's how things cancel out. They're the exact same thing, but one's positive and one's negative. Yes. No. All right. Let's look at the second one. Are these two terms perfect squares?
Yes.
No. Could you make them perfect squares?
Yes.
How? They have a common number. They have a greatest common factor divided both by 2. So the 2 has to be outside. Okay. Now do we have perfect squares?
Yes.
Okay. So that means what are the two parentheses going to be?
Smart.
X plus 5 and x minus 5. All right. Albert, do you have a question? Ooh, good question. What if we had this? That's a great question. What if it's a plus sign in the middle? Okay, so if they were both negative, let's say it was x minus 8 and then x minus 8. Is that what you're saying you should have?
Yes.
Right? Okay, but then x squared minus 8x minus 8x plus 64. Are these middle things going to cancel out? Why not? Because the same thing doesn't make them cancel out. What's the only way to make something cancel out? Opposites. Well, when you multiply opposite things together, are they creating something that's positive or negative? So this has to be a minus sign. It's two perfect squares with a minus sign in between. If it's a plus sign, There was no way that something ever could just disappear without having those opposites. There is no way to make that plus sign. So correct, it is prime.
So that's,
If it is two terms and they're not perfect squares, or sorry, and they are perfect squares, but they have that minus sign in between, then that's going to be prime. What about this?
Oh.
A little bit different. How is this one now different?
Because it's a negative x.
Could this be a difference of squares? How?
Divided by negative.
So this one would work. You would just have a negative sign out in front. Do y'all see the difference between the two? Okay. This is called, and how I remember that there has to be that minus sign between, this is called a difference of two squares. Difference meaning it has that minus sign between the two terms. So flip to the next page. Let's look at number 15. On 15, do we have two perfect squares? No. Could you create two perfect squares? How? They both can be divisible, or they're both divisible by 3. So put a 3 on the outside, and then we have m squared minus 4. Okay, now run through the checklist. After we just did that, do we now have two terms separated by a subtraction sign? And are they both perfect squares? Okay, then they follow that checklist, they're good to go. That means they can be rewritten as a difference of squares, which would be 3, and then what are the two parentheses? M plus 2, and then m minus 2. Just like on perfect square trinomials, I shortened it by PST. Difference of squares, DOS. So next to all these problems today, put either PST or DOS, or neither if it's neither. Okay.